Hello everyone, this is a tutorial for installing Turtlebot3 simulations in robot operating system. This tutorial is part of the ECE 452 robotics course at UIC. First of all, you need to install Ubuntu 16.04. I assume that you already did this step. And then in the project 2 instructions, I need to go to this manufacturer's website, and then I just need to follow this step. If you already did installation of Ubuntu 16, you may skip the 6.1.1, and then the next step is basically installation of the ROS. For that, you just need to copy and paste these 3 lines in a terminal of Ubuntu 16. So just copy and paste, hit enter. Whenever it prompts for the password, just type it. Yep. Depending on the if it's clean installed, it may take a while to run these steps. Then copy the second line. Okay, then the third line is basically will install robot operating system Kinetic version. So since my system has already installed robot operating system, I'm gonna skip this, but this is just a single command line. If you type it in, after a while you'll get ROS installed. So after this step, your system should already have the robot operating system, and then you'll need to proceed for the next step for installation of the Turtlebot3. So before doing that, you also need to install these various ROS related tools. I'm gonna skip that because I already have installed this in my system, but there should be no problem. Just copy and paste to the terminal, and then this part is this will install the Turtlebot3 actually. So after you install the robot operating system, in your home directory you should see catkin_SS. This is short for Catkin workspace, and all your developed packages will be stored inside the Catkin workspace. And once you go in there, so you're gonna see these 3 files, 3 folders, and SRC is in particular very important for you because all of your developing packages will be stored in SRC folder, and including your project 2 package. So since we didn't install any packages, this folder is empty, but once we install Turtlebot3 messages package and Turtlebot3 package, you should be able to see them here. So let's do it. So first, just copy this one by one. And then also, if you don't have a git yet, so you could just install git by typing sudo apt get install git, and just hit enter. You should be able to install it without any problem, because I have already installed, because there's no need for me to run. So once you have a git, just clone this to source file, to source folder. Again, you're cloning Turtlebot3 package into the same directory. So after you download this, so we just copied the source codes of these packages, but to make them operational, we just need to build them. So for that, you need to go back to Catkin workspace folder. So to going back in Linux terminal is cd double dot will go to the previous parent folder, but if you want to go to a particular folder, you could just type it this way and you'll be inside the folder. And yeah, this blue text is the current folder, and this green is the host name and the username. So also, if you want to list the directories in the current folder, you just type ls, and you should see those build level src files, src folders, sorry. And once we're in the Catkin workspace folder, we will run catkin make. So it will build those packages that we have. So our Catkin workspace has been built. Now, if you go to the same folders again in source file, we can see new two packages, Turtlebot3 and Turtlebot3 messages. But that's not over yet, so we still need to install Turtlebot simulations. So for that, we need to go to the another website. Again, in the robotics.com. So for that, we're gonna do the similar thing again. We're gonna clone Turtlebot3 simulation package. Again, you have to navigate to Catkin workspace /src. So we need to go to src folder, and then again git clone Turtlebot3 simulations. Okay, we already downloaded Turtlebot3 simulations, and now it's time to build it. So we're gonna go back to Catkin workspace folder and call catkin make. So the last remaining thing is we need to create our project2 package within the same environment, and then last thing, we need to define our Turtlebot model to be as burger by default. So first, let's go ahead and create our project2 package in the Catkin environment. First, we need to go to again to src folder. So going to src, and then we're gonna call catkin create package project2. So first command is basically, as the name it says, it will create a package, catkin package. The second argument is the name of the package that you want to call, and the last one is the dependency. So our package will depend on the ROS because you'll be programming in Python. And just hit enter, and then we'll go back to Catkin workspace folder again and call catkin make again. So we have successfully created our project2 package in the Catkin workspace, and the last thing, we need to create another subfolder called scripts. So we're going to navigate to src project2, and yeah, so and we're going to create a package, the folder called scripts. The reason is all Python related codes will be stored in the scripts. This is the default configuration in ROS. So as you can see in my file manager in the Catkin workspace /src, we can see all those four packages that we have created. So the project2, this is where you develop your code for the project2. So in the scripts folder, we will just copy and paste the starter code that you have been given in the Blackboard. So for that, I have already downloaded that, and I hope that you can find it easily. So we'll go back and copy and paste the scripts. And the last thing, in order to make it executable, we need to make it executable. So for that, we need to navigate to the same folder again. So scripts, and for that it is just chmod plus and go to point. Now our go to point.py file is executable, and whenever you run ROS run, it will be visible. So, and the last thing is, since Turtlebot comes with two versions, we need to choose the default one. Since we'll be dealing with Turtlebot Burger all the time, we'll just set it as a default. For that, we will just need to have one line to the bash rc file. For that, we're going to open bash rc file in gedit editor and copy Turtlebot Burger. So I have already did that before, so you just need to copy and paste this line. And after that, make sure to source bash rc file, because the changes that you made has to be reflected. For that, you have to source it. Otherwise, it may still complain that some of the programs are not visible. So now we have already configured our ROS environment, and we have already installed all Turtlebot 3 related packages. Now let's see a couple of examples in that. First, we need to run the simulation environment in ROS. We're gonna use Gazebo simulator. So for that, again, we need to go to the Kinetic workspace, make sure that you're in the Kinetic workspace, and then launch. ROS launch, Turtlebot3 Gazebo, and Turtlebot3 World launch. So the first term is a launch command. The second term is the name of the package. The third one is the launch file. And in the launch file, all the details of the execution was all the details of the execution has been specified. So once we click it, Gazebo should come up. So yeah, this is the world, Turtlebot world, and here's my Turtlebot robot, as you can see here. And there are a bunch of obstacles around here. The teleoperation example just simply gives you the control interface of the robot as if you would control a car in the video game. And this is the instructions. W sets the linear velocity, X sets the negative linear velocity, and A and D are for two different rotational velocity. And ROS tool is just nothing else but visual. For example, in the main panel, you can see that these red dots, the leader sensor, it will scan the obstacle around, and every obstacle is reflected as a red dot. And as you can see, it exactly is this map, and this you can see those cones. And the left panel configuration of the sensors. You could add whatever sensor you like, and visual. And ROS is not a required component of the robot functionality. It's just utilization for debugging and programming purposes. The final part of this tutorial is running the task. So the task for you is to command to program the robot to go to specified location in the space. The environment that you'll be using is the Turtlebot empty world. To run that, simply copy and paste in the terminal. So you already in the empty world with the Turtlebot, and you can see this axis. Red line corresponds for the x-axis, the the green for the Y and the blue for the Z. And every grid here corresponds for 1 meter, so 1 square is basically 1 by 1 square. So visually you could say that point, this is 1, let's say if this is trees, and this is the coordinate of this point over here is 1, 1, 3, 0. So 1 in x-axis, y is in the 3 in the y-axis, and the 0 in the z-axis. And if you program your robot should go over here. So the way that you're going to control the robot is already specified in the starter code that is located in Catkin workspace, src project 2 scripts, and here's the code. The only thing is that you will make the logic inside the while loop, and also you could specify the goal point just to make sure that your program works for any other location. This concludes my tutorial on installation of Turtlebot simulations. Thanks for watching.